Hi, welcome everyone to the E+PLC Beginner's Guide. My name is Penny Parker and I've worked for Eurotherm for 27 years, primarily training our customers how to configure our systems. Hopefully you'll be able to follow this webinar through your own PCs, but if necessary there's a conference call too. So what's the objective of this hour-long webinar? We're going to learn how to configure an E+PLC, or at least get you started. And we're going to use a 400 as an example. And we're going to measure two thermocouple values, calculate the average, and set a relay output true when the average is above a user-defined threshold, which we will define. We will also record the values in tamper-resistant UHH files and display the average on an HMI. And yes, we will be able to do all of that in 1 hour. So what about the hardware? Well, in front of me I have an E+PLC400. There's the processor. In module 1 I have an analog input 2 channel with a thermocouple terminating unit, and I've wired in two thermocouples, channel 1 here and channel 2 here, and in module 4 I have a relay 8. So just to recap, the objective is to measure two thermocouples, these two, calculate the average of those thermocouple values, and set a relay output true when the average temperature is above a user-defined threshold. So we'll use channel 1 of this relay 8 module. So the next step is to start CodeSys. I've already installed the E+PLC software, which in turn has installed the CodeSys software, version 3.5 Service Pack 4. So I've already installed E+PLC software, and that has included the CodeSys software. So I can now start a new project. We're going to use the 400 in our example. We can give the project a name if we want. And we should now have a device with 16 slots, and if I double click on backplane I can see a picture of the 16 slots, and I need to tell it that there's an analog input 2 in module 1 and a relay 8 in module 4, and I can do that by right clicking and plugging device and selecting the appropriate module type. So right click, plug device, and select the module type. I can also do that here down the left hand side. I'm just going to cancel that for now because we've only got the two modules that we want to use. And if I double click on backplane and look at the System Configuration tab, it's possible to select degrees C or degrees F or K. I'm going to leave it as the default of degrees C for this example. And the default project that we're building, remember we did a File New Project, so that template provides us with an application and one programmable organizational unit already. And it assumes that we're going to use the CFC language as opposed to ladder logic or structured text. But you can mix and match those languages, you can use all of them, but for this hour-long example I'm going to use the CFC language to do our example. So I need to create a box for thermocouple 1. So we can use our list and Eurotherm standard library and select the appropriate input type, which in this case is TC input. Note that there's a lot of documentation down here which you can read. If I click on OK, I've now selected the type of function block and I'm making an instance which I'm going to call thermocouple 1 for this example. And you can see the declaration here also. So let's just repeat that for thermocouple 2. So create a box, select the type of function block, press return and give the instance a name. So these are our two thermocouples, channel 1 and channel 2. But how do we map that to the hardware? You'll notice that you have our measurement, real measurement, so this will be our millivolt input, cold junction temperature, and the measurement failed status, which is a Boolean, hence the X in Hungarian notation, and the cold junction failed. We also have the enumerated type for the thermocouple type. So we need to map the millivolt input onto here and the cold junction measurement onto there. And we do that by going back to the hardware, the analog input 2 module here, double click, select the second tab, which is the module IO mapping tab, and for input 1 we have a millivolt, a cold junction temperature, the measurement failed state and the cold junction failed state, and we're going to map those to our TC1 instance. So our application contains that unit and this instance and the R real measurement. So that's now mapped to the millivolt input. And we'll now map the cold junction temperature, the measurement failed state, and the cold junction failed state. If we return to the program, you'll notice that you don't have any indication here of the mapping. So the mapping is indicated on the hardware. So let's repeat this for thermocouple 2. So map the millivolt to TC2, real measurement, cold junction temperature, input failed state, and the cold junction failed state. So we've mapped the millivolt, the cold junction temperature, the failed states to our two instances in the program. But the other thing we need to do is tell it the type of thermocouple. So that's the enumerated type here. I can just start typing, then I can select the drop-down list, Eurotherm library, enumerated types, thermocouple, and I'm using a K-type in this example. May want to just move that over. And let's just close this box for now so you can see a bit more. So enumerated type, to start typing, use the list, Eurotherm, enumerations, thermocouple, type. So that's how we measure the two temperatures. If it knows the millivolt input, the type and the cold junction temperature, it will then calculate the actual temperature. So the R output of this instance will be the temperature in degrees C. So we'd like to average those two in our example. So we're going to make a box, and this time we're going to use a keyword to add up the two temperatures. So that's temperature 1 and that's temperature 2. Another box to divide by the number of thermocouples, just as a simple example. Now I could just put in 2 here, but that's not very good programming practice, partly because we may wish to change it in the future, but also because we want to display this and allow it to be changed through the HMI. So we will need to define a variable, an input variable, for the number of thermocouples. So I'm going to connect that to there and give this variable a name. Let's put it number of thermocouples as an example. Give it the type, and you can see it's defined up here. And if we want to initialize that, we can do so here. So this pin will be our average temperature, and we would like to display that on the HMI later. So we will need to define a variable, an output variable, and give it a name. It's a real value, and you can see it's defined there. So the reason we're doing that is because we'd like to display that on the HMI later. So our objective was to measure two temperatures, calculate the average, display the average, and also turn on the relay when the average was above a threshold. So we need another box. We'll use the keyword greater than. That's keyword greater than. So we'll take the average temperature and compare it against our threshold. And again, we could just type in a number, but it would be much better programming practice to have a variable. The real number. I can give it an initial value here. Let's put that as 23. And you can see it's defined up here. So this output will be true or false depending on whether the average temperature is above or below our threshold. And we want to turn on our relay output when it's true. So I've defined an output here. This time a Boolean. But how do we map that to channel 1 of this Relay 8 module. Double click the hardware like you did with the analog input 2. So double click the hardware, look at the mapping tab. There are 8 outputs. We're going to use output 1, and you map that to your variable. Job done. Now we need to just check the code, so we can do build and generate code. And if there are any syntax errors, they'll come up as errors at the bottom here. And we could then investigate them. In this case, there's no errors. So our next step is to download that to the device. I have connected my device with an Ethernet cable to my PC. So if I scan that device, it will find my E+PLC400, and I can then download to it, log into it. There's nothing running at the moment, so I'm going to download my program. Currently stopped, so I can start it here. Gives an indication of the hardware, whether or not the modules are correct. And if I look at the program, you should be seeing live data there, the 2 temperatures, the average temperature, and whether or not our relay is on. So if I hold on to the thermocouple cable and try and raise the temperature above our 23, that's the average temperature above 23, and hence the relay has gone on. And if I let go and let the temperature drop a little, when the average goes below 23, the relay will turn back off. So that's working. Now we could use this as our HMI, but I don't think any operators will thank us for that. So our next step is to create a visualization and display the temperatures and the average temperature in a more user-friendly format. So I'm going to go back offline, logging out, and I'm going to right-click Application and add an object, the visualization object. I can leave the default name or change it, but I'm going to leave it for now. So we now have visualization here and a blank page at the moment. I'm just going to close this to give more space. So we have a toolbox here, common controls, measurement controls, things like bar graphs, and the properties of those objects will be shown here. So let's imagine I just want to display some text. I can do that either by a rectangle, or if I use the common controls, there's also a text field in there. I'm just going to use a rectangle for now. And in the properties, I'm just going to widen this so you can see it a bit more clearly. I want to put something like average temperature equals, and then I have to define the format of the value I'm going to display. This is the sprintf format shown here. So let's have something like 3.1 floating point, and if I scroll down, then I can find the text variable, and that's how I can display or choose the average temperature. So that's the variable that we defined earlier on. Let's also try displaying that as, for example, a bar graph. So if we look in the measurement controls toolbox, there's a bar display there. Various properties. You can select the value here. My click box is just to the right of that, so let's just So to select the value, use the ellipsis there, and again we're going to select the average temperature. We've made a change, so we should do a build and generate some code. No errors. And then again we can go online program is currently stopped, so we can start it with the arrow here. My thermocouple was open circuit, so I've just grabbed hold of it and made it read a sensible temperature, and you can see it's displaying the live value there and as a bar graph. So the other thing we want to do is record the data in tamper-resistant UHH files. So for the time being I'm going to go and log out. Let's just make this a little bit wider so you can see, and let's close this box to give us a bit more room. So we need to add data recording, and you do that by clicking on the device, right click, add a device, and select Eurotherm data recording. And the device will come up at the bottom of the list on the left hand side. You then right click that, add another device and choose a recording group. And you can add several recording groups, however many are relevant to your application. You can rename them if you wish, and when you double click them, you can then select the values that you want to record. So, for example, we could choose to record our TC1 output, which would be the actual temperature. We can add another one. Let's choose TC2. And let's also record the average. You can define how often you want to record them. And you can also configure here colors and parameters for the review package. So once we save this and download it, it will record this data in UHH files, which can then be transferred into review. So again, I'm going to generate code and then download it. So from now on, it's recording this data in UHH files. Now we've only had an hour. We've managed to measure some values, do some calculations, display it on an HMI, and record the data. So if you wanted to transfer it to review, you need to know a bit more, which we won't cover in this webinar, but I would like to point out where you'll find some more information. Help will include the CodeSys help and the Eurotherm help. So you'll find a lot more information here. In addition to the written material, you'll find references here to various how-to demos, which you can see by doing View, Start Page, and looking at the demos. And there'll be recorded demos that you can sit back and watch, and it will show you what to do. For example, there is one to show you how to include batch information in the recorded UHH files, or how to display the recorded data. So you'll find lots more information in the help and the how-to demos. So I think we've achieved quite a lot in an hour. We've measured some values, done some calculations, displayed it in an HMI, recorded the data, found out where to find further help, and downloaded all of that and got it running. So good luck, have some fun, try it out yourselves, and contact us for more details if you want to purchase demo equipment, or if you want to learn more, come on training courses, please contact Eurotherm. Thank you for watching, thank you for listening, and bye for now.